Hello, class. This will be the recorded lecture for section 7.2. And this is calculations, again, using normal distribution, but instead of using z-scores, we're going to do the calculations directly with the mean and standard deviation. Again, you need technology to do this, either your calculator or a spreadsheet. I will show you the spreadsheet calculations. If you want, you could always go back to section 7.1, calculate the z-scores, and use the tables if you really like that. In my day, that's what we had to do no matter what. But the beauty now is technology allows us to skip that step. And so we're going to show you this way as well. And so unfortunately, in my humble opinion, the book did not do a very good job of explaining it. I found it actually quite complicated, to be honest with you. And so what I'd like to do is give this a shot by taking some very strategic examples, actually right out of the Alex homework, and present the problem in a way where I'll show you how to do the calculation, but also show you the concepts and the nuances with regards to that. And so we're going to be using two new distributions or functions, excuse me, in the spreadsheet. First one is norm.dist. And it's just like the norm.inv, except it's going to give you the area less than, but instead of using the z-score, it's using the point, which is x, and the mean and standard deviation. Remember, it always will be true, not only because it's a continuous, but we're always going to be doing less than. And the next one is given a probability or a percentile, and the mean standard, it'll give you a data point that corresponds to that percentile. So I just basically took example 3 from the Alex homework. And it states that we have a normal population with a mean of 36 and a standard deviation of 8. And what I'd like to do is calculate these three. And I'm going to start at the bottom, part C, and work my way up. And so the first one says, what is the probability that a randomly chosen value will be greater than 30? But before I do that, let's sketch this thing, because it's important to understand. This is the idea of the concept and the understanding. So let's see if I can get it decent. That's not too bad. So say like this would be the mean right in the center. And so in this case, this is, let me try again. It's usually better if I do it that way. That's a little bit better. So this is the mean and this is 36. And remember the z-score for the mean is 0. So the mean is 36 and our standard deviation is 8. So if you think about it, if we want to move up 3 z-scores or 3 standard deviations, you go to the right, you add. And so 36 and 8 is 42, and that's a z-score of 1. And this would be, no, this would be 44, sorry. 4 and 4 is 8. So this would be 52, and that would be a z-score of 2. And this would be 0 with a z-score of 3. We go the other way. This would be minus 8, so that would be 28 with a z-score in this case of minus 1. This would be 20 with a z-score of minus 2. And this would be 12 with a z-score of minus 3. And so instead of using these z-scores now, we're going to do the calculations using mean, standard deviation, and the point. And the first one we're talking about here is, we picked the number of 31. And remember, the calculations will always give you less than, and that's what we're doing in this case. So when we do this calculation, make sure I get to the right screens all the time. We go to the spreadsheet and we find the function norm.dist. And you see we plug in the number 31. We plug in the mean of 36. We plug in the standard deviation of 8. And we plug in true. And so that gives you an answer, and I've already rounded it to 4 decimals of 26.6% or 0.2660. And so to help, let me copy and paste the formula and stick it right in our spreadsheet here. And so that's what you would plug into the spreadsheet. And if I wanted to get the number, I could just copy this again and plug in the number right into this. There you go. So if we go back to the whiteboard, this means that the area from here all the way to 0 is 0.266. Cool. Okay, so that's the first question. So our next question is less than 30. How do we do that? Well, again, I'm sorry, greater than 30. I was going to say we just did less than. So our next one is greater than 30. So we're a little bit closer here, right? And so this would be 30. And so how do we calculate this? This would be 1 minus the probability of x being less than 30. So what we want to do is do the norm.dist for 30 and then subtract it from the number 1. And so to do that calculation, and I usually do it in a single cell, but you could do it in 2 different cells. So let me show you how I do it. So I hit the equal sign and then hit the number 1 and then minus, and then I plug in the function. And so norm.dist would be 30 in this case. Again, the mean is 36. Standard deviation is 8. And this would be true. So if you see that calculation, you get 7734. So let me copy and paste this, put this into our PowerPoint that I made up here. And so that would give you the answer, and I should be able to, so if I copy it again, I could just paste the number. So, but I could do that one shot, but I could. There we go. So if you go back to our whiteboard, what do we have? Well, we know that this answer here was 0.7734. And does that make sense? Well, if you think about it, you're below the mean. So if you're going up, it needs to be greater than 50%. So that makes sense to me. And you could see that where it shows up in the point here, that it would, it feels right when you take a look at the graph. Okay, so the last one. Let me erase this. And so the last one, and they use some weird words. I've never seen this in a book before, but it's pretty easy to translate. So this last one, which is part A, is what proportion of the population is between 19 and 28? They use the word proportion analogous to probability. So it's the exact same calculation, except what you're looking for is the probability or the area between 28 and 19. So let's go back to our whiteboard and take a look at that. And so 19 is right here. So right below here. So that's the number 19. I'll put it up here so we can see it better. And the other number is 28, which would be right here. So we're looking for the area between those two. So you could see it's not going to be a huge area. If you got a number like 80%, you're like, I did something wrong. So the idea is it's going to be an area pretty close between the area of z equals -1 to -2. So the way you do that, it's the difference between the two. So it'd be x less than 28, which would be all of that going down, right? And then it'd be minus x less than 19. So basically you would take this and subtract it off, and then you end up with that amount of area there. So when you go to the spreadsheet, I usually do this in one cell as well. So I'll show you how I do it. So the numbers again were 28 and 19. Gotta jot those down so I don't forget. And so it would be more functions. And the first one would be 28. That's the bigger one. 36. Standard deviation of 8. And true. And so you could see that at 30, you have 15% from 28 all the way down to 0, right? So now we want to subtract. So I go up to the formula here and do minus, and then come back and do one more DISD. So in this case, you get 19, 36, you get standard deviation of 8, and you get true. You can see the difference between that would be 14.2% or 0.1419. And so let me cut and paste that and stick that into our presentation here. So you have that available. And let me stick that number in there. And that would be the number. And so if you went back to the whiteboard, this area between here is 14.19%. So you can see that kind of feels right as well. So this is a really good demonstration, including using the bell shape or the bell curve, excuse me, to give you a nice demonstration on not only how to do the calculations, but where they fit on the curve as well. I really hope this helped. And so the next recorded lecture, we'll go through talking about percentiles and finding data points given that percentile.